So, we're starting a little bit late, so I'll try and finish as close to lunchtime as possible, so you don't all run after me and complain there's no food left. My name's James. I've been a developer for more than 20 years. A vast majority of that time has been doing event sourcing, distributed systems. One of the things I've come across and used quite a lot is process managers. So this talk is called Beyond Aggregates because sometimes when you're trying to find a way to solve a problem, actually the way aggregates work gets in your way. But I'd really like to start by doing a quick review of the terms we're going to talk about so that I'm saying something and you will understand what I mean by it. Okay, so what is a pattern? Most people don't think about this. It's a generic solution to a recurring problem, yeah? But implementations of the same pattern may vary. And any specific implementation that you have may have different constraints due to the environment or the domain, or even the language that you're using. This description is not one I've made up. This comes from a book which I'd recommend reading if you're interested in patterns, called Patterns of Software Architecture 5. I'd start with the 5th book and then read through the rest of them. The aggregate pattern. So now we've talked about what patterns are, we can talk about specific patterns. It comes from the domain-driven design book, the blue one. It's about a cluster of domain objects which represent a consistency boundary for enforcing invariance. Yeah? Generally, in the blue book, it's called an aggregate root, what you're accessing. So generally, we shortcut that to aggregates. When I say aggregate, I invariably mean aggregate root. When you create an aggregate, you name it for domain concept. This gives you part of your ubiquitous language. We've done the last part. The other terms that I come across or bring up, I will introduce as they come up, but those are the two really important ones. Patterns, an abstract, generic thing that we can use to solve problems, but the implementation of them may be different. So I'm going to put some stuff up here as to ways that you could implement process managers, but what you need to do might be different. You have different constraints. I only have PowerPoint as my constraint. Okay, when do we use aggregates? When you need to force a business invariant. That is their primary job, right? Yeah. Generally, when we're doing event sourcing, we do that in response to a command. Okay. Really, you only want to use them when the invariant uses a small set of data. I require all usernames to be unique, not a good aggregate use case. Yeah. When your business process is a series of actions on a single aggregate. Yeah, so if you think about an order, you might go through an order where you just go through the different stages of the order and it doesn't actually talk to anything else. Seems probably not that useful, as you probably want to ship it, but you might be picking that up using an event-driven architecture or doing something else. You might not have communication between them. When do you not use them? Replacing unique constraints. The whole username must be unique. Enforcing, which comes down to enforcing invariance over a large data set, right? Interacting with other aggregates and objects in the same domain, unless you're querying. You do not want to be going in someone else's consistency boundary and playing around with it. You've just broken the boundary. In fact, what you've done is you've doubled the boundary. And the bigger your boundary gets, the harder it is to actually do things with it. Interacting with things outside of your domain. Well, if it's consistency boundary and you just brought in another domain, now your consistency boundary is out of 2 domains. What about some third-party system outside your control? Now your consistency boundary includes your payment provider. These are not good things to do. This is what we need, something other than an aggregate to be able to deal with these kind of problems. So what is a process manager? And when should you use them? And more importantly, I go into quite a lot of reasons why you shouldn't use them a lot of the time. It's a pattern for orchestrating processes. The clue is unfortunately quite in the name. It manages processes. It's very hard to come up with something inventive to say about that. But it's particularly of use when the steps cannot be fully known in advance. Yeah, I want to reserve some tickets. Oh dear, we've run out of tickets. I have to do something else. Maybe put you on a waiting list. Yeah, it's designed to interact with multiple components, so you can have it interact with other components in the same domain, usually aggregates, might be read models, across domains, where it's coordinating between the domains, and between completely separate systems. So this is how you integrate with the outside world. If your system doesn't integrate with the outside world, it's probably a little over-engineered if you're using process managers. They're a messaging pattern. They're not a software design pattern for writing code. They're a pattern for doing messaging. It's part of a subset of messaging patterns called routing patterns. I've got a message and I need to know where to send it. I need to decide to send a message somewhere. Yeah? It's a hub and spoke style of messaging. Now, hub and spoke gets a lot of bad press, but what it basically means is if you send a message out, then your process manager is going to get the response. That's really important because that's how it makes decisions. Why am I talking about it here? It's a messaging pattern, right? And event sourcing is essentially a software design pattern. Message is a pattern for communication. These are all from the Enterprise Integration Patterns book. Commands are a subset pattern of message used for invoking functionality. Events are a subpattern of message used for reacting. Right? Well, we've got commands and events. And actually what event sourcing does is it prolongs the lifetime of a traditional event message so that we can use it to rebuild state. Therefore, I come to the conclusion that we're using messages, and therefore I can talk about messaging patterns. The other thing is that when you're writing process managers, which are just dealing with messages, actually event sourcing the state can be quite useful because it helps you keep the state small. So, there are some really big pitfalls with using process managers, right? You have to be careful. These things are dangerous, they have teeth. If you've got a long-running process that runs for years, yeah, it is going to accumulate a lot of state. That is not a good idea. You'd need to manage different versions of it. Hands up anyone who's put a version of software live and never had to put another one live again without leaving the company. There are no hands. So, it's a hub and spoke style of messaging. This means you've got a single point which the messages for that process must go through. That can have performance implications, particularly if you're doing high volume trading, for example. Yeah? So you need to be able to scale out your process managers. If all of your processes have to go through to the same process manager, you've just created a bottleneck. And that's not going to help anyone, and you'll have to think about it again, unless you only have one user. They're incredibly flexible, which is a plus point, and a really bad point, because you can use them to implement pretty much anything. And the hard bit is knowing when not to. So I generally tend to use process managers as the last tool in the toolkit to reach for, because it's too easy to use them too soon when there might be a better option. They often need some additional infrastructure, right? Process managers generally want to know about timeouts. You communicate with process managers using messages. You need some way to send messages on a timer to your process manager. You're going to have to build that, or find something that does it for you. One way you can do it, for example, is some queuing technologies allow you to say, send a message, but don't make it appear until this point in time. That's a timer message. There's fairly easy ways of doing these things, but you still need them. You need some way to report on the state of all of your process managers. Because when a customer calls up and says, hey, order 123 doesn't seem to have shipped, what's happening? Well, if you can't tell from the process manager, or from your state of where things are in sort of like your read models, you're going to have to go and look to see, did the process that was running that process manager die and not recover in the way that I expected it to? Where did that process manager for that thing get to? So you have to build that. You need a strategy to fix bugs in running processes. Yeah? You can't say, sorry, your order will be delivered after the next software release and you replace the order. That's not going to work. Fixing something that changes the previous state is error-prone and difficult. If you don't test it properly, you could end up in an invalid state and make the problem worse. This is a quote from Enterprise Integration Patterns, where I took all the messaging patterns from. I'm going to read this verbatim. So this is Gregor Hopper, and he has this very short section. I think it's like 3 paragraphs on process managers. This is one of the paragraphs. First of all, let me clarify that the design configuration of a process manager is a pretty extensive topic. We could probably fill a whole book, volume 2 maybe, with patterns related to the design of workflow or business process management. This is a big topic, and we are only going to scratch the surface of it. But the reason I want to talk about it is they've been mentioned and hand-waved around for a long time, but no one's actually, I don't think I've ever seen anyone actually talk about this before. Now, my talk is all slides, yeah? But Jeremy, who's speaking after lunch in this room, his is all code, talking about the same thing. Yeah, so if you want to see an example of how you can implement them, see his talk. I want to talk about theory. When do you use them? Orchestrating processes that require multiple aggregates. It's the #1 reason that I've used them. Yeah, I've got an aggregate here which is nicely encapsulated, aggregate here which is nicely encapsulated. The problem I've got is they're 2 different aggregates and they need to coordinate somehow. I don't want to put that logic in the aggregates. Calling to aggregates and other domains. Sometimes you will use this as part of an anti-corruption layer between domains. It's a useful pattern there, like a very useful pattern there. Calling out of the domain to other systems. Yeah. Hey, I should probably bill a customer's credit card here, but I don't want to write all the credit card billing software. Simplifying communication between the domain and other systems. So sometimes you are dealing with maybe some form of infrastructure. If you're working in something which is doing some kind of control, you might be talking to infrastructure. Infrastructure is difficult to deal with. It does not play nice with domains, right? But you might need to have some negotiation with the hardware to be able to get it to work. Dealing with time. Yeah, I want a timeout. Very hard to write an aggregate that uses timeouts without filling up all your history with timeouts. So I've got some examples of what we're talking about. Now I'm going to take you through these slides and hopefully leave enough time for some questions at the end. But the 2 that I've picked is a reservation pattern, so reserving a ticket. It has other applications. You can apply it to anything which has some form of constraint you want to put on it. I have even, as long as you don't tell anyone, I have even applied it to email must be unique. Okay, it does work there. You need a few cheeky tweaks to make that work, but it does actually work. calling a non-idempotent API. So imagine if Stripe wasn't idempotent. And you had your web app call your backend with some retries, so it does it 3 times, and that calls the thing behind it 3 times. So now that's 9 times. And now you call Stripe 3 times with your retry logic. So now you just charge your customer 27 times. They are not going to be happy about that. Yeah. So, Stripe's API is idempotent. It's idempotent for that reason. But not everybody designs their APIs like that, and some people design APIs that are super costly to call multiple times. So, has anyone here heard of the reservation pattern before? A few people. I can't see because there's light in my eye. Was maybe 10, 15 people. Okay, this is a pattern built using a pattern. You may choose to build it differently. You may need to build it differently because your system has different constraints. This is an example of how you could do it. I'm going to go through the pattern, both patterns. First of all, trying to do it using an aggregate, and then showing what the difference with a process manager is, so we can compare the two and see whether or not we think it's going to be better or worse. So the problem statement. You want to sell tickets to I usually insert whatever I'm speaking at here, conference. The tickets are limited. Yeah, you cannot overfill the conference. There are fire regulations. People don't like it if they have to sit on each other's laps for the entire conference. They're going to get grumpy if you oversell. You can't sell the tickets until payment has been completed. But we don't want to wait more than 10 minutes, because if our conference is popular, and someone takes a day to pay, they're going to think our conference is sold out, and then we're not going to have anyone taking that ticket. The idea is to sell all of the tickets, and this is a trade-off to try and sell all of the tickets, but give someone enough time to go and find their credit card. Cannot take payment for tickets that are not available anymore. If you're in e-commerce, generally, you say, yep, order in some more, ship them when they come in, hope the customer is patient enough to wait, if not, refund them. With a conference, that person you just sold a ticket to is booking a plane ticket. That might not be refundable, right? And a hotel. I'm planning a trip. There's a different, not all, refunds are created equal. So, what would this look like with an aggregate? Now, I never get the colors right for all of the sort of like event modeling pieces and things like that. I can never remember which colors are which. So these probably don't line up with the event modeling colors. Orange is a command. Blue is an aggregate or business process. Green is an event. Have I got it completely back to front? I normally get it completely back to front. Okay, so what we're going to do is we've got someone going to request 2 tickets. It goes to our ticketing aggregate. Why does it go to our ticketing aggregate? Because we need to be sure we've got enough tickets to be able to sell. So we're going to, when we apply the order placed, we're going to decrement the available tickets by 2. We're going to increment the reserved tickets by 2. There's a reason for that. And we're going to add the order to pending orders. Okay. We're going to make a payment. We've got Magic Stripe widget for making payments. We're going to do this through the website and pretend that there are no problems with doing that at all, because that's a completely different subject. We're going to tell the ticketing aggregate that payment has been made. Then we're going to move the order to completed orders. Should probably also subtract those tickets from the reserved ticket column. Right. Timeouts. We need another thing, which is running in the background. sending, hey, if this order has, if you've got orders which have expired, they've taken more than 10 minutes since the order was placed, and it hasn't moved to order completed, you need to cancel those and put the tickets that you just reserved back into the available ticket pool. Now, I'm pretty sure anyone that's done event sourcing knows that this is a terrible idea for how to implement this using aggregates. Why? So, we can only process one order at a time, right? Because an aggregate is a consistency boundary. If I process 2 orders at a time, yeah, I can process a message for different orders, one after another, but I cannot process messages from multiple orders at the same time. I have made the entire thing single-threaded by accident. We cannot process actual things that people want to pay for, like payment, whilst we're processing timeouts, because those messages go into the aggregate, and those have consistency boundary too. Orders usually contain customer details. Who is buying the ticket? Do you have a plan for GDPR? Yeah, I'd like my details removed from the middle of this aggregate that you've put them in. There aren't that many options for dealing with that. You either throw away your immutability of event streams, or you rewrite the entire stream without that data in it. Now, there are limited options for dealing with that kind of problem. And the reason for this is because you made your state too big. So what we're going to go, we're going to extract the process from the aggregate. Yeah, because this masks internally the process that we were talking about the business having, which they told us quite nicely up front what the process is. So, pink, process manager. You're going to order 2 tickets. That's going to create an order. Sounds a bit more like domain-driven design already. Actually, order tickets creates an order. Yeah. Get an order placed event. Yeah. We add in an order number in here because it helps correlate things together. We want to be able to correlate to which process manager and which order we're talking about. Yeah. It's going to generate a command to something to reserve 2 tickets. It's going to go to a ticket inventory. This ticket inventory, conceptually, again, singleton. But all it needs to do is keep a count of how many tickets are in there. That contains no personal information, and an event containing a number is really tiny. Yeah? If you really have a problem with that, you can shard it into pools. Yeah, so you can get around that problem, but you've made the problem small enough that we can now start to deal with it. So our ticket inventory is going to reserve our tickets. It's going to tell the order processes manager, who's going to listen for those events. It doesn't have to tell it directly because it's listening to the event stream, that it's reserved the tickets for that order. Well, now it can say, great, I'm going to issue a new command, assign tickets to order. I'm going to send that to the order. So the order knows that it's got tickets assigned to it. Yeah? Now, we can say, hey, user interface, we would like you to get payment from the customer. Magic widget, because payment's complicated. Make payment goes to the order, so we make the payment on the order. And the order faces payment made. The order process manager says, great, complete the order. Yeah? Now, one of the things you can do here, if you're event sourcing your process manager, is you can write out into its stream that the order is complete, but it's in its stream. It needs to go back and tell the order that the order is complete. You need to maintain state for process managers because they need to maintain state between calls. If you've got a volatile process, then you just need to keep that in memory. But generally, processes which take 10 minutes are not considered volatile. You want to store that somewhere. Complete order goes to the order, raises order completed, and sends you, congratulations, you've got tickets, you're going to DDD. Okay. Are we done? Timeouts. Pesky timeouts. Timeouts are always pesky. Because time in problems makes things more difficult, because time is not very easy to deal with if you don't abstract it. So this is where we were when the order was placed, and we need to reserve tickets. Our process manager, he doesn't have to do one thing at a time. He can do two. Yeah? Process managers can actually handle multiple asynchronous things going on in parallel at the same time and coordinate back all of the things which come back. Bit more tricky, but with timeouts, it's a super easy way to do it. So we create a timer. We're going to send that somewhere. We give it a delay, a timeout. Oh, timeout order, which is actually the message that we want to get back with the order number in it, so we can know which order we're timing out. Yeah. Now, to keep these things separate, the order number becomes part of the address of order and the process manager. Yeah, so you can actually have a separate one of these for every single order. So the state is super small. It is literally all of the messages that you've seen on here, but only those per order. If you need to delete one, you delete one. Okay, where does that go? Well, it actually comes back to us. So the timer service's job is to take that message that we sent it and send it back to us when the delay has finished. Why a delay and not when we want to change? Well, not when we want to time out. The reason we put delay in is we actually, for course timeouts like this, we want the timer service to calculate a delay from when it received the message for the timeout. Clock drift. It's a real thing. You don't want to send the timer service a message saying, call me back in 10 minutes, have the time service 10 minutes ahead, and immediately time you out. I can't place orders, says the customer. It just says your timeout expired. I couldn't even get my credit card out. That won't work. Going to send a timeout order to the order process manager. The order process manager has state. It knows what state it's in. If the order is completed, it can ignore the timeout message. Yeah? And there is nothing faster than receiving a message and dropping it on the floor and doing nothing with it. It's like writing to dev null. It's really fast. It's going to issue a cancel order command. It knows whether or not we've taken the payment. Right? It knows if it's in process, if it's in the process of finalizing. It doesn't need to issue cancel order if it knows it's finalizing. We make payment on the order. The order is the consistency boundary around where this is going to. What I have not shown in any of these arrows here is that's a command. The order is allowed to reject it if it's received the payment. When it rejects it, the rejection goes back to the caller. The caller is the process manager. Yeah, so it is going to handle commands that were rejected. So you don't have the problem of not knowing whether or not you've made payment. Now you might, because of the timing issues with payment, you might say, hey, I'm calling the payment provider now, and put it so that you don't end up taking the payment and then getting rid of it. But you can also immediately, if you realize you've taken the payment, refund the customer immediately before telling them they've got tickets. If you can refund the customer immediately before telling them they've got tickets, then they're not going to book a flight to come, right? So your refund in that case becomes okay. Sidebar, building timers. Said you can use a event stream, a message queue. If your message queue has functionality to delay when a message appears on the queue, you can use that as a cheap timer service. And we're talking high, sort of like large times here. We're not sort of talking like, I need to time out in 500 milliseconds, otherwise you flood your timer service with messages. 500 milliseconds, that's a volatile timer. You know, something that doesn't persist the time to disk, doesn't deal with crash recovery. If you don't come back up within 500 milliseconds, well, your timeout happened anyway, so just forget it. You do need to design for that. Crashes do happen, even in cloud. If you've got a 10-minute timeout, you can actually implement this fairly easily with an event stream because all of your timeouts are the same. And because we send a delay to the timer, you can calculate when the timeout actually happens by the time you publish the message into the event stream and the period of the delay. And we know that all delays are the same, so you need a different stream per delay time, but you generally don't have a lot of delay times for this kind of thing. So we've just got a 10-minute one, right? So we just need one stream. We write events at the end of the stream, and then our timer service reads from the beginning of the stream, yeah, and it stops as soon as it finds an event that has not yet expired. So one which was published, and when you add the publish and the delay together, it's not yet expired. However, if we find the ones which have expired, we publish them. Yeah. Then we want to wake ourselves up when the next one expires. Now, that sounds like it's going to go forever. However, it doesn't, because as soon as you've published them, you can delete them. Right? So you can truncate the beginning of your stream. So you've got something which is chasing along. So you've got a stream which is exactly 10 minutes worth of timeouts. Are there some drawbacks for this? Yeah, sure. There are more moving parts. Yeah? It is not command aggregate event. You need to think about it a bit more. You needed to write a timer anyway, because that loop that you had, expiring events, well, you don't want that to run in a continuous loop, because if it's running a continuous loop, it will block orders going into the aggregate, so you're going to want to wake up periodically and expire the event. Yeah, you still needed a timer, you just didn't realize you needed it. There are more messages being used, both commands and events, but there are less stored in each component, in each stream. That's really quite critical. We like to keep our event-sourced components really short streams. Trust me, it's better than snapshots. There were actually two aggregates hiding in our first attempt. Yeah? There is the concept of an order and the concept of a ticket inventory. If you are struggling to make a process work with one aggregate, maybe you're missing some. Then maybe you need a process manager to orchestrate them. Maybe you don't. Covered off that. Oh yeah, done GDPR. It is much easier to write resilient components with this. Yeah, because you can, the less state you have, the easier it's to recover, and the easier you can pick up back off from where you were processing without affecting too many things. And that is way better than being called at 3 AM in the morning by an irate ops guy saying your code has done something terrible. So, dealing with the neighbor from hell. I've got my system here. It's a very happy little system. It's going to interact with the system here next door, which is very badly behaved. So we've written our aggregate. It models our domain quite nicely. Forces all the business logic we've got. It relies on a third-party service that is less reliable than our domain. It is super expensive to retry. Yeah? Fortunately, it doesn't fail that often, but when it does fail, it invariably requires human intervention. to protect the innocent, yeah, we're going to pretend this is provisioning in a web, in a cloud VM, right? It's very close to the truth, because actually you do have this problem provisioning cloud VMs. Data centers run out of PCs. If you're automating provisioning, yeah, and you start billing your customer for something which you've provisioned, and the data center comes back 10 minutes later and says, "Nah, we didn't have any of those left." Then, unless you have picked that up and made damn sure that you're not charging your customer, you're going to have a customer with a very, very big bill, and they're not going to be happy because they didn't get it. What might it look like? Get request to provision an instance. Goes into our customer topology aggregate, so we know what the customer actually got. We write that we've had a provisioning request. We call the provisioning API. We write the event we've provisioned, and we save state. Oh. Where in the process are we? How do you know? This is pretty much impossible to do with straight aggregates, because each time you process a command, you come out in a consistent state, and then how do you call an API if you're in a consistent state? How do you end up in a consistent state if you've processed a command, especially one that can fail? Your consistency boundary has just grown to include the entire API that you were talking to. Bad news, especially if you don't have any control over it. How do you detect errors? If in the traditional way of saving events, I raise an event, process it, call the API, process it, say that I've done it, process it, save it, it goes boom in the middle. Well, how do I know where I got to? How do you detect that it broke? Can you do crash recovery? This thing isn't just the API failed, it's your process got yanked by the data center that it was on, because they're migrating your machine to somewhere else. Yeah? There are lots of reasons you can fail while making that call. The network was unreliable. We can't just reject a command partway through processing if we haven't ended up in a consistent state. Because if we've called that API and provisioned that box, someone's getting a bill for it. So when do you save state? What happens if you crash? How do you do failure detection? Specifically in the face of crashing. I think I duplicated that slide, sorry. Possible solutions to it. Can we use an anti-corruption layer? You know, it's the go-to thing in DDD. Hey, I've got two different domains which are talking to each other, anti-corruption layer. Well, you still have to deal with the messaging problem, you know, in your anti-corruption layer. Maybe you put your process manager in your anti-corruption layer, but you still have to deal with it somewhere. Hope for the best. You just got a huge bill and you've got no idea why, because you just threw away the fact that the customer requested you provision a machine, and the data center, they did not forget that you provisioned the machine. They remembered and they sent you a bill. Your customer got a huge bill. You thought you'd provisioned the machine wasn't provisioned, you've billed your customer. They're now angry on Twitter. Yeah? Can we use Process Manager? Maybe. So, provision instance goes into our customer topology. Provisioning requested goes to provisioning process manager. This uses a cheeky trick. So, and we can do this because it's not an aggregate. There's no consistency boundary required here. Refresh? Oh, green is event, blue is business process. Also sort of business process for the repository. The pink thing just says it's the same instance. I must really try and remember exactly what the colors are every single time I do this. Right, so when we get provisioning request, that's going to create a new instance of our process manager. Yeah, we're going to cheat. We're going to give it an instance ID when we create a new one. Yeah, we're going to say we start provisioning, and then we're going to save state. Yeah, and then we're going to hand our own event. There are other ways of doing it. You could also choose to just have your persistence logic call back in with a next step, so you can just iterate on essentially do a while true, there's next step, but do the persistence where you need to do it in the process. It's got the instance ID in it. If it's the same instance that we saw, that we currently have loaded, then we'll call the provisioning API because we didn't crash in between. So we know we can't have called the provisioning API here because we're in the same instance. That response is going to come back into our provisioning manager. And assuming it was successful, provisioning completed. The error case is pretty obvious, provisioning failed. Right. I've duplicated that slide too, sorry. So, if you have a crash, no, that's why this one's here. So we've got to this state where provisioning was completed in the process manager. Then it's going to inform the customer topology that provisioning is completed. And that is when we can start billing our customer, because we know we safely provisioned the instance. We've got a record of everything that we did. If, when we're processing our provisioning requested, the instance of the provisioning process manager isn't the one that we hit, because it's got a different ID, then we can say provisioning is an unknown state, and not actually call the API, and say help, human help. Okay, let's see. So, the initial state, we cheat, it is an empty. Traditionally in aggregate, you start with empty state. Now, we don't. We say, actually, we're going to have an instance ID in our initial state so we can detect failures. This is okay. There are other ways of doing this too. This is just the way I chose. Like I said, it's a pattern. You know, your implementation may be different, but these are the things you have to think about. We apply the state change as normal, including provisioning started. If provisioning started has a different instance ID to the one we're at, unknown. Then we can alert on unknown states. Great. Now we've got failure detection. We only call the API once ever. Nobody gets bills that they weren't expecting, and we can call for help when we need it. So, in conclusion, there will be time for questions at the end, and I will be around for the rest of the conference if people need to talk to me. What are process managers? They're a generic solution to workflows. They are literally workflows. Workflows are a recurring problem. You come across workflows all the time in business. Sometimes you explicitly want to model it as a workflow. Your environment, domain, and even programming language will have an effect on how you implement them. Yeah? You can implement workflows using step functions. If you don't have step functions, you can't implement them using step functions. But you can, there is a lot of existing infrastructure out here to do this. You don't have to build your own. Sometimes it's necessary to build your own because you can't find something that does what you want, or you only need it for a very small part and it's reasonable enough to do it. Or you have a lot of them and it's actually worth owning that. There are lots of options, but you are going to have to evaluate it in your domain. This is not a cookie cutter, one size fits all kind of pattern. You have to think about this. So you consider them when you need to coordinate in domain, particularly if binding process and aggregate together are causing you pain. When you need to coordinate between domains, and when you need to coordinate between different parties or different systems. Benefits. Hope. We've seen from the diagrams that there are some things in here which are benefits. They're explicitly for modeling processes. They can massively simplify your aggregates if you've inadvertently embedded process in your aggregates and it's causing you problems. You can create really complex behavior from simple components. None of these things was particularly crazy busy in terms of what it was doing. Yeah, but we can actually create quite a lot of complex behavior from that. Complex behavior from complex components is not complex behavior, it's just complexity. And a headache. Warning, they do come with a health warning. Process managers are capable of being used for pretty much anything, right? If you use the same pattern to implement everything, what you have is a hammer. If you have a hammer, every problem is your thumb, and eventually it will start to hurt. Yeah? They're incredibly useful when you need them. Don't overreach for them. They can be the only reasonable way to solve a problem. And they're nothing to be scared of. A lot of people shy away from them because they think they're going to be big complex beats. They're actually really generally simple components. You can chain them together. I'm pretty sure Jeremy's going to talk about that later as well. You can chain processes managers together so that you've got process managers coordinating sets of processes. Simple components, complex behavior. If you'd like to learn more, particularly about patterns in general, I recommend the Patterns of Software Architecture books. Start with Patterns of Software Architecture 5, because that one tells you what patterns actually are, and then you can go and read a lot about patterns, understanding them in a much better way. I did it the wrong way around. Then I had to go back and do it the other way. Enterprise integration patterns. Event sourcing is a form of messaging. Yeah? If you're doing event sourcing, you should read enterprise integration patterns, because there are lots of patterns in there that you can apply to various places in your event sourcing, particularly if you're using events to do event-driven architectures where you're then sending messages outside of your domain. And you're going to want those messaging patterns. Questions? I've got approximately 2 minutes left, but started late, so you might want to go to the lunch, I don't know.
Any questions? I would like to really throw it out. Almost.
Close enough. Are sagas a form of process manager?
I should have prepared for that. Sort of. So they're often, the way sagas are often described now, they're what I'd call a process manager. A saga was initially in the initial saga paper, it was written to perform distributed transactions. So you'd basically go to system 1, perform the action, go to system 2, perform the action, go to system 3, perform the action, go to system 4, it blows up. So now you go to system 3 and roll back the action, system 2, roll back the action, system 1, roll back the action. Process managers have logic, and things come back to the central location, and you can make decisions that you can't using classic Saga. But a lot of people implement even classic Sagas as process managers. So you can use process manager to implement pretty much anything, including a Saga. But a Saga is not a process manager, in my opinion. The word is a bit confused.
Same. Any more questions?
In your example, did the instance ID come from us or from the third party?
For the provisioning?
Yeah.
New unique ID.
But is it ours? So did we generate it?
We generate it.
So in that case, so what if the cloud provider? Where do we store that in the cloud provider, right? Because it's not going to match the instance ID that they have.
So it's not an instance ID that we're doing. It's an instance ID for our process manager. Like think of it like I create an object, yeah, and I give it an ID. Yeah, the cloud provider, he's going to create some object to do the provisioning. He's going to give it a separate ID. But my object is that I know that my object is still in memory and still the same one that I'm talking to.
Got it. So now the real question then is, what happens if I have that instance ID on this side and then something gets created on that side, but then I don't receive the acknowledgement, but it did get created. And now, like you said, you end up with a huge
So,
bill.
well, in that case, where are we? If that's an error, then we can say it errored. If we never got the response, then we're in provisioning state unknown. Please ask human for help.
Got it. Okay. Cool.
Any more questions? I won't be trying to throw it.
To me, a process manager seems a lot like a state machine. And how wrong am I?
You're not wrong at all. It is a state machine that has the ability to send messages to other components and might contain routing information. It's a routing pattern with a state machine inside it.
Hey, in your example, the input for the process manager is usually an event, but how does the timeout example go to the process manager? Is it the timeout is an event, or how is it modeled? Do you call the process manager directly?
So are you asking how it knows which one to go to, or why I used events and commands to activate the process manager?
Yeah, you use commands and events to call
so
a process manager?
traditionally people say that process managers should only respond to events. My experience of process managers is that there's a limiting arbitrary restriction on them that isn't useful. The reason it's a limiting arbitrary restriction on them is sometimes you need to have some way to stop a process, right? Stopping a process isn't an event, it's a command. So do I have to write, hey, somewhere, and where do you put this event? There's an event that my process has been requested to be stopped, and I'd like my process manager to subscribe to that so that it can get it and stop the process. Per unique stream, for example. This becomes like really hard to deal with. It is better to have some way of routing commands to them if you need to be able to take interactions to them. I believe personally that timeout is a command because you say to the process manager, I'd like you to time out. Yeah, and it goes, well, that's not an event. I've already completed the order. So I think you have to have both.
Okay.
I'm going to hang around probably near the event store stand. And I do respond to people if they have questions, if you ask me via any of these. I will probably put the slides up on my GitHub later today. Just haven't got around to it yet.
Please give a really strong applause to James.
Thank you.